Hi, I'm Chaim Gurfink. I'm professor of atmospheric science in the Earth Science Institute, and I'll first talk about most of the Rosh Chug of the atmospheric science Chug in Hebrew University. So I'll talk first about my own research and then about the Chug more generally. So my own research focuses on subseasonal predictability. So the forecasts currently over the first week or so are very accurate, but once you get beyond a week up to a month, forecasts are essentially useless. There's essentially zero scale once you get beyond a week. And so the goal of my research group is to try to understand how we can lead to forecasts that are actually useful beyond a week. And in particular, there's certain processes in the atmosphere that have characteristic timescales that extend beyond a week. And the goal is to understand how these processes work and then how they could lead to surface climate predictability on month ahead or even 2 months ahead. And there are such processes, and we're working on that. And these processes are important not only for weather forecasts and on shorter timescales, but also for climate change timescales. Models that do a better job at capturing some of these processes that are important on these shorter timescales, in the case of Europe and over Israel as well, simulate qualitatively different climate change impacts. So, for example, some models that fail to capture these impacts will find in general stronger climate trends over Europe than models that have a weaker, that do a better job. And so we try to understand these processes and how they can lead to surface climate predictability and skill, and then understand the impacts on climate change as well associated with these processes. So that's about my research group. I'll focus now on the Chug more generally. So we have the largest Chug of atmospheric science in Israel. We have faculty members whose interests range from tropical dynamics to mid-latitude dynamics, from clouds to radiation. So for others, we have a brief survey. So one faculty member focuses on clouds and how clouds interact with climate change. And basically, clouds are the biggest uncertainty in climate change. So models that, in terms of the magnitude of climate change. So some models simulate, let's say, 4 degrees of warming over the next century, and some models simulate only 2 degrees, and some models simulate 6 degrees. And to understand why there's this difference among the models, we have to look at clouds, and also, so one faculty member looks at that. Another focuses on radiation and how radiation impacts clouds and aerosols, which are small particles in the atmosphere. And that also is very important for understanding whether climate change will be 2 degrees or 4 degrees or 6 degrees over the next century. Another faculty member focuses on tropical processes, so monsoons, where rainfall occurs in the deep tropics, and understanding how that will change, how that is determined in the present climate and also in the future, and how that responds to external forcings. Another faculty member focuses on class changes, understanding how the atmosphere changed over the past millennia and past several centuries. And finally, another faculty member focuses on extreme weather, extreme floods, and how floods impact, how extreme rain leads to floods, both in Israel and also outside of Israel. And then again, my research focuses on subseasonal variability. And so that's it. If you have any questions, either about my own research or about the Chug more generally, I'd be happy to take questions, and I hope to see you all at the Yom Batuach. Thank you.